Hi, Algebra 2 students. After finishing your quiz in class today, you want to go ahead and watch this video to work through the notes for section 5.3. Section 5.3 may just be the easiest chapter in all of chapter 5. All we need to do is put some of our exponent rules in action today to add, subtract, and multiply polynomials. So today should feel like basic foundational operations with polynomials. There are no graphs and there are no real-world applications. So it should be a pretty quick and easy unit to get through. So the first thing we want to do is to work with our addition of polynomials. So for our polynomial addition, and let me make sure I'm at the start of these notes here, we have two different techniques for how we combine polynomials when adding and subtracting. We can work either horizontally or we can work vertically. A good rule of thumb, though, is that it can be useful to write your polynomials in standard form first before you do any other operations. So if we look at these two polynomials, so you can think of this as polynomial number 1 and this is polynomial number 2 that we want to combine together in addition, let's write these in standard form so that the highest valued exponent is coming first. So here, this one's going to be 2x to the 6th plus 7x to the 5th plus 2x cubed minus 4x. So notice I just reordered that polynomial so the highest degree valued term was coming first. And I'm going to do the same thing over here. So negative x to the 9th is the highest degree. Then I've got 8x to the 6th plus 3x cubed and then minus 2x. So you guys, the reason I like to do that is that way I make sure I'm accounting for all of my terms and then I make sure I don't miss any terms. So we've been talking about multiplying and dividing exponents. When you go to add terms with exponents, you can only combine terms that are exactly alike as far as their exponents go. So the highest valued term we have as far as degrees is this negative x to the 9th. But that's present in the second polynomial and not the first one. So it can't be combined with anything else, so we're going to be left with a negative x to the 9th. Then what we have, if we go to match our exponents, are these x to the 6th terms. So we have a 2x to the 6th and an 8x to the 6th. Those we can combine together to get a 10x to the 6th. Then if you take a look over here, this polynomial has an x to the 5th, but the other one doesn't. So that one just needs to come down here. Then we have a 2x cubed and a 3x cubed. So that is going to be a 5x cubed. And then we have a negative 4x and a negative 2x. So if I add those together, I'm going to end up with a negative 6x. So I'm just going to go ahead and box this up, and I'm good to go. That's my final polynomial added together. So pretty straightforward. I'm just looking for combining like terms in these operations. In your next note section, what you have is a slide that asks you to combine them vertically. So some people prefer addition vertically so they can see very clearly which terms are going together. So when I do this operation vertically instead of horizontally, I'm going to write out my first polynomial. Again, I'm going to put it in standard form first. So this guy is going to be negative 3y to the 8th plus 7y to the 5th minus 2y to the 4th minus 4y. And then I'm going to add this polynomial over here, and I'm going to copy that down. Now, if we notice here, I have a y to the 6th, so that wouldn't necessarily align up with anything. So it's kind of up to you how you want to align your terms. A lot of times we like to put terms that are exactly alike right next to each other. But if I have a y to the 6th, I'm not going to be able to fit that in anywhere, so I could kind of put it in between right here like this. And then plus 2y to the 5th, I've got another minus 2y to the 4th, and I've got a minus 8y. So however you want to kind of align them up, it's best if they are directly underneath the ones of the same degrees, but if you have some that are mismatched, if you kind of fill in the spaces there. So if we go to add these down, this negative 3y to the 8th has to come down because there's nothing it can combine with. Same thing with this y to the 6th, so that's going to come on down. But then I can put these two terms together, the 7y to the 5th and the 2y to the 5th, and I'm going to get 9y to the 5th. I can add these two negative 2y to the 4th and get negative 4y to the 4th. And then I've got a negative 4y and a negative 8y, so I'm going to have a negative 12y. And that's my final answer there. All done. Combined my like terms, added similar valued exponents together, and then left the terms that didn't have any like terms alone to get the final answer there. Subtracting polynomials is what we have up in our next set of examples. These operations are exactly the same. So you want to go ahead and convert them into standard form first. So my highest degree is already in front here, but then I'm going to move this 4a to the 4th. This minus 3a plus 1 is good there. And then here, 3a to the 7th needs to come first, but then I've got a plus a to the 5th, a minus 9a to the 4th, and a minus 8a here. So when we start combining like terms, we have a 2a to the 7th minus a 3a to the 7th. So we're going to have a minus a to the 7th. Now, notice we've got an a to the 5th over here, but not over here. So I'm just going to end up with a minus a to the 5th here. Then I can combine these guys. So I've got minus 4a to the 4th minus negative 9a to the 4th. So I want to be careful there that I properly distribute this negative. So if you picture this operation, negative 4 minus negative 9, that means I'm going to end up adding 9. So negative 4 plus 9, that's going to give me positive 5. So I will have plus 5a to the 4th. That takes care of those terms there. Then what I have are these linear terms. So I have negative 3a and then minus 8a. So here, same thing, I am subtracting a negative. So I've got minus 3a minus negative 8a. So I'm going to be adding here negative 3 plus 8. So that's going to end up giving me 5a. And then last step, I just have this constant, but I don't have any terms over in the other polynomial to combine that with. So this is just going to be the polynomial that I end up with. Negative a to the 7th minus a to the 5th plus 5a to the 4th plus 5a and then plus 1. So same thing, combining like terms. And then you can imagine we did addition vertically. We're also going to do subtraction vertically. So if we go to write these expressions out in standard form, my first one, I'm going to write this 9c cubed out in front. I'm going to leave a little bit of space just because I don't have a quadratic term here. So I'll have plus 8c and then minus 3. So that's that in standard form. For my other polynomial over here on the right, I've got c cubed, that's my highest degree. And then I've got a minus 13c squared, minus 2c, and then minus 4. So I can line it up like that. Now in this case, we're going to be subtracting. So let's go ahead and do that subtraction operation. Here, 9c cubed minus c cubed, that's going to give me 8c cubed. Now I don't have any c squared. You can think of this almost as if I had a 0c squared hanging out here. So 0 minus negative 13, that's the same thing as 0 plus 13. So this is going to be plus 13c squared. Then I'll have 8 minus negative 2. That's the same thing as 8 plus 2, so I can combine my linear terms to get plus 10c. And then I need to do negative 3 minus negative 4. So negative 3 plus 4 means my final result here will